Okay, hello, assalamualaikum. So, today we are going to present our report about PSR and EFIS. So, okay, wait, whoa. So, this is our team 2, which is we have Sheikh Omar Fikri, metric number 205451. We have myself, Amir Akmal, 207152. And also Ganesh Rao 206116, Iskandar Zulkarnain 207515, and Muhammad Afiq Zufairi 208314. So next, the objective of this report is to know the development of the modern aircraft. Next, to study how PSR work in determining the position of an aircraft, and the third one is to investigate the benefits of EFIS on aircraft. So the table of content. So first thing first, we are having an introduction of PSR. What is PSR? And next we continue with working principle of and application of PSR. So how it works for aircraft industry. That is the key thing that we not want to know how about PSR. So the third thing, introduction of EFIS. So what is EFIS? The definition of EFIS. And the last one is working principles and application EFIS. How it helps pilot for handling an aircraft. So this is a quote by Leonardo da Vinci. When once you have tasted flight, you will forever walk the earth with your eyes turned skyward. For there you have been, and there you will always long to return. So they are by Leonardo da Vinci. So we continue with introduction of PSR by my teammates. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iskandar Zulkarnain bin Hasno Isham. My matrix number is 207515. I'm from group 2 and today I'm going to present about what is PSR and a brief history of PSR. Okay, firstly, what is PSR? PSR is also known as Primary Surveillance Radar. It is a conventional radar sensor. It illuminates a space with electromagnetic waves and receives back the wave from the target. This is the methods in which it used to consider where the target is. It has good horizontal resolution and can scan 360 degree around the site. It also provides distance and radius speed of the target with good precision, which means it is highly accurate. And for the history of PSR, the earliest experiment involving the idea of a radar came in late 1880s by a German physicist named Heinrich Hertz. However, radar was originally developed to be used in war, most known as in World War II in the 1930s until 1940. One of the earliest working radar was made in 1922 by the US Naval Research Laboratory. It happens when a ship sailing on the river causes fluctuations to the signal. However, the US Navy was unwilling to support and sponsor this work. The principle of radar, the principle, the principle of radar was rediscovered 8 years after that by L.A. Hyland when he observed that an aircraft flying through the beam of a transmitting antenna caused a fluctuation in the received signal. A decade later, on 1940, Massachusetts Institute of Technology Radiation Laboratory developed microwaves radar that meet the new military capabilities. After that, more than 100 different radar systems were developed as a result of the laboratory's program. After the war has ended, radar which has highly accurate monopoles tracking and large high-power radar was developed. In 1970, technology experiences significant advance, thus enhancing the ability of radar. Nearly a decade later, the radar have developed to a point where it can distinguish one type of target to another, which means it can differentiate between an aircraft and a ship. Advances in remote sensing made it possible to measure winds blowing over the sea level, ocean roughness, ice condition, and other environmental effects.
So now I'm going to talk about working principle of primary surveillance radars, also known as PSR. So how it's work, basically PSR will transmit a high signal power that eventually will be reflected back by the aircraft. So PSR will have this antenna that constantly rotating on top of the tower, and it can transmit an electromagnetic wave, and the aircraft will reflect it back. This will effective around a range of 60 nautical miles. So basically, how it determines the positions of the aircraft is by the times elapsed. So there's a simple physics behind this. If you want to check it out, you can check it out on the internet. So basically, it just calculate the time elapsed between the transmissions and receptions of the electromagnetic wave, and then the systems itself will calculate the distance and will provide you with the angular measurements in a spherical coordinate of the aircraft. So PSR is actually totally passive, means it does not require any actions from the object that it track. And then so we know that PSR is a very accurate radar systems, but we do not know the altitude and the object that reflects the wave, the electromagnetic wave. So we solve these problems with operating the PSR together with the air traffic control radar systems. All the cool guys just call it SSR. So in short, how it's work, for a long range, the PSR will need to transmit a very high signal power. So while considering the environments, considering the interference from the environments, so that's how it's work. And then it can transmit an electromagnetic wave up to 2700 to 2900 megahertz. So that's how PSR works.
Hi, my name is Samuel Fikri. I will explain about EFIS. What is EFIS? EFIS is stand for Electronic Flight Instrument System. Firstly, the meaning of EFIS is a flight day instrument display system that display flight data electronically rather than electromechanically. EFIS, also known as glass cockpit, is a key component of any modern aircraft. Have four components, which is primary flight display (PFD), multifunction display (MFD), and an engine indicating and crew alerting system (ECAS) display. Now, EFIS models more common use liquid crystal display LCD than cathode ray tube CRT display. Mostly, EFIS uses dedicated signal generators to drive two independent displays in the center of the basic T. The complex electromechanical attitude director indicator, which is EADI, and horizontal situation indicator, which is EHSI, were the first candidates for replacement by EFIS. An EFIS installation will follow the sequence, which is display control and data processor. A basic EFIS might have all these facilities in the one unit. Flight crews must gain perfect knowledge of cockpit system of each aircraft type in order to control it safely.
For primary surveillance radar, there is 6 applications. First of all, navigation, which will help us to ground mapping and weather avoidance radar, and also ensure the location of obstacles. Next, visibility. It provides invisibility and measures the proximity of other ships. Third, traffic, which will guide aircraft for proper landing and takeoff, and detect the proximity and the altitude of the aircraft. Next, military operation. PSR will help for Navy, ground and air defenses, which is used for detection, tracking and also surveillance. Fifth, law enforcement. For this, extensive use of radar during pursuit and get clear images of traffic when bad weather. Last, track and detect, which PSR will help us to detect the position of the target and remote sensing, and also detect the weather condition and track motion. These PSR applications looks common, but it will be very helpful for different sectors. Thank you.
So now I'm going to talk about the working principle of electronic flight instrument systems, also known as EVIS, but let's just call it EVIS for the sake of simplicity and for the sake of my presentations. So EVIS consists of primary flight display, navigation display, and electronic altitude indicator directions. Altitude direction indicator. Sorry. So in some designs, actually they will integrate those two, which is EADI and the navigation display, into one. So now let's talk about how it's work. EVIS. EVIS actually consists of 3 symbol generators, if you're looking at the picture provided in the slide, and that are connected to 4 display units, which is primary flight display and navigation display. So if you look at the pictures, the SG1s, which is the symbol generator 1, is connected or is a format for the PFD and ND1. So it's actually a display unit for the captain that are piloting the aircraft. And then SG2 are connected to PFD2 and ND2, which is for the first officer that are assisting the pilot, the captain. So to aid the crew with critical informations during flight, EVIS actually provide the airspeeds, Mach speeds, altitude, altimeter, airspeed, and it's also constantly self-monitoring itself, and also have this specialty what we call as comparison data. So first, let me talk about the monitoring capabilities. So what actually is a monitoring capabilities? So these monitoring capabilities will help in comparing the two information for the captain's display units and the first officer display units. It will detect if there is differences between those two display units. So that's what I call of self-monitoring. Also, it's self-monitor the airspeed and other informations during flights. And then let's talk about the hot sphere. If you look at the picture, in the middles of in between the SG1 and SG2, there's what we call as hot spheres or SG3. So what is the function of SG3? SG3 is actually is what we call as a spare units. So in some cases, I mean, like if something happens or either the two malfunctions for certain factor, it will automatically replace the SG units. If SG1 failed, it will replace it. It will replace the SG1s, and same goes for SG2. So let's go back to the comparison data. So what I mean with comparison data is actually so comparison data means, like I said just now, it will compare if there's an error between both display unit or symbol generator. And then like I said just now, the EVIS will aid the flight crew with informations during the flight, the critical informations. So what are the units that provide this data? So this data is actually integrated standby instrument systems, or the cool guy just call it IS. Yes. So in short, in short, what I mean is basically there are two channels in IFIS. One is the externals and the other one is internal. So what is internal channel do? What does it do? So internal basically just providing the data that you receive from sensor, multiple sensor, to the display units. And for the externals, it will do the same thing, except it will compare the two display units, and it is also responsible for any changes. I mean, like if there's any error in the display units or any sensor input. So externals basically just detect if there's an error in the sensor input.
Hello, Assalamualaikum. So I will explain about application of IFIS. So first thing is, IFIS is equally designed to illustrate the glide slope scale and on pointer only during an IL's approach. Next, when situation involves the pilot's attention to a single object, a declutter mode automatically triggers. So they will take the pilot attention, so then the pilot will aware with what happened to the aircraft. Next, if its electronic projection system has no such limitation and uses color extensively. Next, in order to represent the navigation type, standard IFIS systems have color code. So the navigation needles have their own color codes. As an example, mm, green needles suggest navigation dependent on the land. VORs, localizers, and ILS structures. Magenta needles suggest navigation by GPS. So then this is the example of the color code that used by IFIS. Next, and the last point, IFIS becomes standard equipment on most Boeing and Airbus airlines. This shows that IFIS is a thing that very important in every aircraft. So that's all from me. Thanks to all of you for watching this video, watching this presentation of our team. So if you have any question, you may ask after this video. So thank you.